Today we are going to learn about mastering NumPy Reshape for data preprocessing. We'll explore how to manipulate array shapes to enhance preprocessing workflows, equipping you with essential skills for efficient data preparation.
Welcome to our video on mastering NumPy Reshape for data preprocessing. In this session, we'll delve into the world of NumPy, focusing on how reshaping arrays can be crucial in preparing data for machine learning models. Efficient data preprocessing ensures consistent input dimensions, a fundamental requirement for robust machine learning applications. By the end of this tutorial, you'll be proficient in manipulating data shapes to enhance your preprocessing workflows, streamlining your data preparation process for better results. Let's begin by understanding what reshaping means in the context of NumPy. Reshaping refers to changing the dimensions of an array without altering its data. This is done using the reshape function, which allows you to specify the new shape you want for your data. The syntax is straightforward: array.reshape new_shape, where new_shape is a tuple representing the desired dimensions. It's important to note that the product of the new dimensions must equal the total number of elements in the array. One common confusion is between reshape and flatten. While reshape changes the array's dimensions, flatten converts it into a one-dimensional array. Let's look at a simple example. Suppose you have a 1D array of 6 elements. Using reshape, you could transform this into a 2x3 matrix, a 3x2 matrix, or any shape where the product of dimensions equals 6. Understanding these basics sets a foundation for more advanced reshaping techniques. Reshaping is a frequent task in data preprocessing, especially in machine learning and data analysis. One common use case is in image data processing. Images are typically represented as 3D arrays, height, width, channels, and reshaping these arrays is often necessary for model inputs. For instance, a dataset of images might be reshaped into a single array with dimensions suitable for feeding into a neural network. Another example is in time series analysis, where data might be reshaped to create sequences for recurrent neural networks. In machine learning, batch processing requires reshaping data into batches of consistent size, enhancing model training efficiency. Reshaping is also crucial when preparing data for neural networks, ensuring the input dimensions align with the network's expected input shape. Furthermore, when dealing with multidimensional data, such as sensor data or 3D models, reshaping helps in organizing this data into a format that's manageable and analyzable. These examples highlight the versatility and necessity of reshaping in data preprocessing. While reshaping is powerful, it can sometimes lead to errors, especially when the shapes are incompatible.
A common error encountered is the cannot reshape array of size x into shape y, z error.
This occurs when the total number of elements in the original array doesn't match the product of the new shape dimensions. To resolve this, it's crucial to first ensure that the number of elements remains consistent. One strategy is to use the -1 parameter in the reshape function, which lets NumPy infer the appropriate dimension size. For instance, if you have a 1D array with 12 elements and you want to reshape it into a 3D array with a fixed depth, you could use array.reshape 3, 2, -1. Here, NumPy calculates the missing dimension automatically. Another tip is to thoroughly check the input data before reshaping. Ensure that no elements are missing or extra, which could lead to shape mismatches. Additionally, understanding the intended structure of your data can help in troubleshooting and resolving shape errors effectively.
In NumPy, reshape and resize are often confused due to their similar names and functions. However, they serve different purposes and have distinct behaviors. Reshape is used for changing the shape of an array without altering its data, and it requires that the new shape be compatible with the number of elements. Resize, on the other hand, can change the array size by either adding new elements or removing existing ones, which can affect data integrity. This means resize can increase or decrease the total number of elements, filling new elements with zeros if needed. When should you use each? Use reshape when you're confident that the number of elements remains constant, and you merely need to alter their arrangement. Resize is useful when you need to adjust the number of elements, such as expanding a dataset or truncating it to fit a specific size. For instance, if you're working with a dataset that must fit a fixed input size for a model, resize can be handy, but be cautious of the potential data loss or padding. It's essential to choose the right tool to maintain data integrity and achieve the desired preprocessing outcome.
To solidify our understanding of reshaping, let's explore some practical examples with real-world datasets. We'll start by loading a dataset using NumPy, such as the popular MIS dataset for handwritten digit recognition. This dataset consists of 28 by 28 pixel images, which are 3D arrays. Often, these images need to be flattened into 1D arrays for certain machine learning models, requiring reshaping. Another example is handling missing data in a dataset. Suppose we have a time series dataset with missing entries. By reshaping the data into a 2D format, we can apply imputation techniques more effectively. Let's also consider a practical example with Python code. We'll demonstrate loading a dataset, applying reshaping techniques, and preparing the data for a machine learning model. Through these examples, you'll see how reshaping is applied in real-world scenarios, enhancing your ability to preprocess diverse datasets effectively. Performance is a critical aspect of data preprocessing, especially when dealing with large datasets. Reshape operations, while powerful, can impact performance if not handled efficiently. One key consideration is memory usage. Reshaping an array doesn't create a new copy but rather a view of the original data, which is memory efficient. However, if a copy is explicitly required, it will consume additional memory. Understanding when to use views versus copies can significantly affect performance. For instance, if you need to modify the reshaped array independently, a copy is necessary, but for read-only operations, a view suffices. Another optimization tip is to batch reshape operations, minimizing the frequency of these operations to enhance performance. Additionally, leveraging NumPy's built-in functions can lead to more efficient data handling compared to custom functions. Balancing performance and accuracy is essential, ensuring that optimization efforts don't compromise data integrity or analysis accuracy. By applying these tips, you can optimize your preprocessing workflows, achieving faster and more efficient data handling. NumPy's power lies in its ability to perform complex data manipulations efficiently. Integrating reshape with other NumPy functions can enhance your data preprocessing workflows. For example, combining reshape with functions like concatenate, stack, or split allows for sophisticated data transformations. Consider a scenario where you need to partition a dataset into training and test sets. Using reshape alongside split functions, you can efficiently organize and prepare your data. Another example is chaining functions for efficiency. Suppose you're normalizing data, applying transformations, and reshaping for model input. By chaining these functions, you streamline the process, reducing the need for intermediate steps. Handling complex data manipulations becomes more manageable, leveraging NumPy's capabilities effectively. Through examples and demonstrations, you'll see how integrating reshape with other functions enhances data preparation, making your workflows more efficient and robust. Maintaining data integrity is paramount in data preprocessing. When reshaping arrays, ensuring accuracy is crucial to prevent data corruption. One best practice is to validate reshaped data, checking that the transformation has been performed correctly. This can be done by comparing the original and reshaped data, ensuring no data loss or distortion. Documenting preprocessing steps is another key practice. By maintaining a clear record of each transformation, you enhance reproducibility and facilitate debugging. Leveraging tools for data integrity checks can further enhance accuracy. For instance, using assertions or checksums can verify data consistency before and after reshaping. Additionally, understanding the intended purpose of each reshape operation helps in aligning transformations with analytical goals. By following these best practices, you ensure that reshaping enhances, rather than compromises, the quality of your data, supporting robust and reliable analysis.
As we conclude this tutorial on mastering NumPy Reshape for data preprocessing, let's recap the key takeaways. We've explored the importance of reshaping arrays in data preprocessing, crucial for preparing data for machine learning models. You've learned how to manipulate data shapes, handle errors, and integrate reshape with other NumPy functions. We've highlighted practical applications and best practices for maintaining data integrity. As you continue your data preprocessing journey, practice is key to mastering these skills. We encourage you to apply these techniques in your projects and explore further resources to deepen your understanding. Thank you for joining us, and we wish you success in your data preprocessing endeavors.